Hi, good morning to my lecturer, Puan Syahidah. Today we will make a presentation about trigonometry in badminton. My group members is myself, Idlan, also Helmi, Arfan and Rafiq. Trigonometry in badminton. The trigonometry, the branch of mathematics concerned with specific functions of angles and their applications to calculations. There are 6 functions of an angle commonly used in trigonometry. Their names and abbreviations are sine, sin, cosine, cos, tangent, tan, cotangent, cot, secant, sec, and cosecant, csc. Third one is trigonometry in badminton. The effect of hitting the shuttlecock is strange. No matter how hard you hit the shuttlecock, it won't go much further than about 6 or 7 meters. The terminal speed experienced by the cock when it is under influence of gravity is determined by the strength of gravity, air density, the size and mass of the shuttlecock, and its smoothness. A parabola is formed when we hit the shuttlecock. It falls steeper than while rising. From a mathematical point of view, the trajectories of shuttlecock are a bunch of mathematical functions. Real life application, trigonometry can be applied in various ways in the content of badminton. Here are a few examples. Shot placement. Trigonometry can help players determine the ideal angle and trajectory to place their shots. By understanding the angles and distance involved, players can strategically aim for specific areas of the court, making it harder for the opponent to return the shuttlecock effectively. For the second one, smash technique. Trigonometry can aid players in executing powerful smashes. By analyzing the angle of the shuttlecock trajectory, player can adjust their body positioning and swing to generate maximum power and accuracy, resulting in a more effective smash shot. For the last one is serve placement. Trigonometry can help players strategically place their serve. By understanding the dimension of the court and the optical angles, players can aim for specific corners or areas, making it challenging for their opponents to return the serve effectively. Overall, trigonometry can enhance a player's understanding of angles, distance, and trajectories, allowing them to make more informed decisions and execute shots with greater precision in the game of badminton. The formula of trigonometry. As you can see, the formula for sine A is equals to A over C equals to side opposite equal hypotenuse. Second, the CSCA equals to C over A equals to hypotenuse over side opposite. Cos A equals to B over C equals to side adjacent over hypotenuse. SECA equals to C over B equals to hypotenuse side adjacent. For tan A equals to A over B equals to side opposite equal over side adjacent. COTA equals to B over A equals to side adjacent over sides opposite.
Here are things to know before we start with the question. A badminton court is 13.4 meters long and 6.1 meters wide. If we're using single player rules, each player will only use half of the court, which is 6.71 meters long and 4.88 meters wide. We'll move on to the question itself, which is, we got a diagram over here, and the question is, if the shuttlecock will land on point B, the player must go to point B to catch the shuttlecock before it lands. So what is the angle of the player's position, which is B? Okay, we already have the measured diagram. We have opposite, which is 4.88 meters wide, and adjacent is 6.71 meters long. We need to find hypotenuse, which is over here. We're gonna use tangent theta equals to opposite per adjacent. That is the formula, so we just put in the number. So tangent theta equals to 4.88 meters per 6.71 meters. Gonna move theta at the back, so it will become theta equals to tangent -1 times 4.88 meters per 6.71 meters. The answer will be 36.3 degrees.
Assalamualaikum and hi, I'm Muhammad Rafiq. I want to give one example question about trigonometry badminton. Before that, I want to let you guys know that we can apply badminton as an example for trigonometry in maths. For the right triangle formation, when the shuttle is hit, first, the line of impact acts as the vertical side of right triangle. Second one, the horizontal distance to the landing point is the base. The third point is the shuttle trajectory is the hypotenuse, and the last one is the angle of the smash, which is theta, is measured from the horizontal. And people will ask why it matters in maths. Why it matters in badminton, a steeper angle, which is larger theta, makes the shuttle first will be land closer to the net. The second one will harder for the opponent to react, and the last one is less likely to go out of bounds. A shallower angle, which is smaller theta, travels farther but gives opponent more time to respond. Okay, now we got a example question in diagram, and the question is: a badminton player jumps and hits the shuttle from a height of 2.4 meters above the ground. The shuttle lands at a point 4.0 meters away horizontally. A. What is the angle of the smash with respect to the horizontal? B. If the player had hit it from a height of 2.0 meter but with the same landing point, what would the new angle be? Okay, now we know that we got a formula, that the formula is tangent theta equals to opposite per adjacent. And now we know that our opposite is 2.0 meter and our adjacent is 4.0, and we just need to put it in the formula, which is tangent theta equals to 2.0 meter per 4.0, and it will be theta equals to tangent inverse times to 0.5, and the theta will be 26.6 degrees. And the second question is, which is B. We just do the same thing, that just need to put it put the number that given in the question, which is height 2.4 meter. 2.4 meter equals to our opposite. So tangent theta equals to 2.4 per 4.0, and theta equals to tangent inverse times to 0.6, and the tangent and the theta equals to 31 degree. So the answer of A is 26.6 degree, and the answer of question B is 31 degree.
Weight of the shuttlecock is 4.05 to 5.5 grams. The diameter of the cork is 25 to 28 millimeter, 0.98 to 1.1 in. The diameter of the circle that the feathers make is around 58 millimeter. The shape, it has 16 feathers with each feather 70 millimeters in length. It has an open conical shape. Weight of the shuttlecock is 4.05 to 5.5 grams. The diameter of the cork is 25 to 28 millimeter, 0.98 to 1.1 in. The diameter of the circle that the feathers make is around 58 millimeter. The shape, it has 16 feathers with each feather 70 millimeters in length. It has an open conical shape. The backchord drop shot looks like y equals ARC tan x. The trajectory of a backhand short serve has a function of y equals to cos x. Long serve can be represented by the following function equals 5 sin x. And this is the low serve trajectory.